Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about what is efflorescence and how to remove it. Efflorescence is a crystalline deposit of salt that can form when water is present on brick, concrete, stone, plaster, or other building surfaces. It has a white or grayish tint, and when water evaporates, salt accumulates behind. In addition, efflorescence can appear as a powdery substance on floors and walls and requires special care for treatment. What are the causes of efflorescence? You can see efflorescence both indoors and outdoors, and it can vary in frequency and intensity across the country due to humidity and temperature. There are three main reasons for this. The presence of water-soluble salts. Moisture available to convert salt into soluble solution. Being able to transport the salt through a material to its surface. The moisture will then evaporate and cause the salt to crystallize, resulting in efflorescence. Water, rain, and snow are the primary sources of moisture and can affect the degree of weathering. Condensation, groundwater use, and indoor activities can also affect the degree of moisture production. Efflorescence can occur due to various building surface installation problems, including incorrect use of through-wall flashing, use of masonry without adequate ventilation. Use masonry in areas that lack proper moisture. Use of masonry in areas that lack a proper moisture barrier. Joint material failure. Unwarranted ground storage. Improper ground storage. Efflorescence is often a seasonal problem, and moisture will affect whether soluble salts appear. It usually grows in winter, as rain, snow, sleet and other inclement weather conditions can occur. However, flowering may still occur in spring, autumn, and summer. How to spot efflorescence? It is important to understand the difference between flow and stain. Stains usually come in different colors, but may appear similar to efflorescence at first. Efflorescence is a white, powdery substance that can be found on an uncovered surface, including brick. Since it is aporous material, brick can absorb soluble salts. To find out if efflorescence will be a problem for your brick, take a brick and submerge it in distilled water for about 7 days. Allow the brick to dry after 7 days and compare it to the brick that was not submerged. If you see white, powdery material on the brick, it is less likely. Cement. According to the Brick Industry Association, BIA, Portland cement represents an important contributor to weathering in mortar and grout. It is higher in alkali and is more likely to be used than other types of cement. Conversely, it is important to note that all types of cement contain some water-soluble alkalis, which make any cement susceptible to weathering. Lime. Lime is soluble in water and can react with unaffected hydrochloric acid to produce calcium chloride that can travel to the surface of a building material. In comparison, lime has also been shown to improve the bond between mortar and brick and increase the water resistance of masonry materials. Sand. Sand is used in mortar and grout and is not soluble in water. On the other hand, sand may be contaminated with a material that may contribute to weathering. For the construction of projects, the use of clean, washed sand coming from sources free of contamination will reduce the potential for weathering to develop. Clay. Building brick and face brick consist of clay, which contains highly soluble salts. Clay can react with calcium sulfate resulting in flatulence. Admixtures. The bonding and strength of an admixture can increase the ability of weathering with a building material. In general, precaution with admixtures is preferable. If you do not know which mixture is included in yourself, you may want to avoid this solution altogether. Any construction material that comes into contact with the ground may be susceptible to erosion. But if you know the root causes of efflorescence, you can choose the right building material and prevent this problem from happening. Efflorescence salts are associated with many building materials, including calcium sulfate, a common effluent salt source in brick. Sodium sulfate, often seen in cement brick reactions. Potassium sulfate, noticeable in many cement brick reactions. Calcium carbonate, can be found in mortar or concrete backing. Sodium carbonate, often seen in mortar. Potassium carbonate, like sodium carbonate, usually found in mortar. Vanadyl sulfate, commonly found in brick. Magnesium oxide, often present in brick. Choosing the right construction material is paramount for any construction project. If you understand the impact on various building materials and how to detect the effect, you should have no trouble mitigating this problem. How to prevent efflorescence? There are several solutions to prevent efflorescence, including hydrophobic sealant. The absorption of water can be prevented by applying an impregnated hydrophobic sealant on the surface of a construction material. The sealant will also prevent water from traveling within a construction material. Capillary breaks. Establishing capillary breaks as a polyethylene sheeting between a building material and soil can reduce the risk of salt entering the material. Quality masonry construction. Applying overhauling coping, eaves and flashing will reduce the risk of water in a wall. Emphasize increased landscaping and sprinkler. Increased emphasis on landscaping and sprinklers. Landscaping will ensure that the focus of sprinkler that can prevent you from reaching the porous building materials to water. Installing grout with mechanical vibration. Integrating grout with mechanical vibration will limit the possibility of voids in the grout. Using dense tooled mortar joints. Using dense tooling mortar joints reduces the porous nature of a wall, making it harder for salts to drain through it. Utilizing grouted mixtures. Grout exudators, such as chemical additives that are designed to improve the flow of a grout mixture and reduce its water content at the same time, reduce the voids in the grout. Can be reduced. Storing masonry materials properly. Keeping masonry materials off the ground and covering them with waterproof materials can protect these materials against groundwater and rain. How to remove efflorescence. Some of the best methods of efflorescence removal include pressurized water. Efflorescence can dissolve quickly by applying pressurized water. If you use water, then dry the water from the construction material after application. If you fail to drain the water, crystals may remain, which may cause fluorescence. Diluted vinegar. If you are in a pinch, domestic diluted white vinegar can be used at efflorescence. It is less harmful than industrial chemicals and you already have vinegar in your kitchen. Brushing. With a strong brush, you can easily remove efflorescence. Removing efflorescence can be quick and simple. In fact, effluent salts are soluble in water, which means that weathering can disappear on its own due to normal weathering. It is important to complete this task in hot, dry climates in order to clean the cleft from the brick. At this point, moisture can bring excess salts to the brick surface, and the salts can be removed by dry brushing. Clean water repellents, silicone, and acrylic coatings can also help you remove efflorescence as well. The coating will absorb water on a masonry surface and prevent erosion from recurring. In addition, a combination of hot water and white wine vinegar has been shown to eliminate indigestion. To apply a coating correctly, you want to use the following three-step process. Rinse the building surface. Rinse the building surface with water. If the surface is outside, you can use a hose to spray the surface. Or, if the surface is indoors, you can use a spray bottle filled with water to rinse the surface thoroughly. Apply the cleaning solution. Spray the cleaning solution on the surface of the building and let it sit for several minutes. If necessary, you may need to apply several coats of cleaning solution to the surface for optimal results. Rinse the building surface again. Rinse the building surface with water one last time. Then, use a fresh, dry cloth to clean the surface. Ensure that the surface is dry to minimize the risk of ongoing immaturity. Apply 1/8 inch to 1/8 inch below the surface of the building material. This will prevent water from evaporating and passing through the treated area in the form of vapor and soluble salts. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.